This video is over how to solve systems of equations using substitution. Most of this should be review, but just in case, we're going to go over it in detail. First, substitution means the act of replacing a person or thing with another person or thing. So in substitution for systems of equations, we will substitute one variable in one equation with the entire side of a second equation. So here are three different sets of equations. Each one is going to be solved for a different variable. Okay, first you have this equation where we're going to solve for y. This equation we're going to solve for x. And this equation we're going to solve for x. Now the reason for these choices, if you notice, each of these variables has a coefficient of 1. And that just makes our life easier. That's why I'm picking these to solve for. So time for the first example. Like I said, we're going to solve for the y in the bottom equation. So out of 2x minus 3y equals negative 2 and 4x plus y equals 24, the y in the bottom equation has a coefficient of 1, so that's what we're going to solve for. So picking that equation, I'm going to rearrange everything so that I have y equals. Now I'm going to take this entire equation and substitute it into the top equation. And to do this, I'm going to replace the y in the top equation with the right-hand side of my first equation, or how I solved for my first equation. And you can see that in blue. After that, it's just regular algebra. Distribute the 3 and solve for x. So now I know what x equals, but what does y equal? Well, to do that, we're going to take the answer that we just found for x and plug that in, or substitute it back in to one of the equations, the top equation in this case, and then we're going to solve for y. And again, we are just using basic algebra steps here to find these answers. So after solving this time, I can tell that x equals 5 and y equals 4. Now when you write the solution of an entire system of equations, you need to write it as a single point. So I write 5, 4, and this is a coordinate on a graph. So you can see this is a lot of work, but the difficult part is really only the first couple of steps. Everything else is just solving for x or solving for y, like what we've been doing the past 3 weeks. So this second example is going to be a little bit different because it deals with fractions. Now, as I said on a few slides before, we're going to solve for the bottom equation because the coefficient for x is 1, and that just makes our life easier. So first, rearrange the equation so that you have x equals. So x equals 4 plus 3y. And we're going to take that and substitute it into the top equation, replacing the x in the top equation with the right side of the formula we just made. After that, distribute the 6 and solve the equation for y. Now that I have an answer for y, my next step is to find the answer for x. And to do that, I take this y answer of negative 19 over 20, and I will substitute it back into the equation so that I can find x. Notice I'm replacing where the y should be with the number negative 19 over 20. Now to find this fraction, I did cheat a little bit. I used a calculator and had it tell me what the fraction would be. Because like I've said before, I prefer fractions instead of decimals as final answers. And of course, since I now know the x answer and the y answer, I have to write the final answer as a set of coordinates. So I have 23 over 20, comma, negative 19 over 20. And that's my final answer. So again, it is kind of tedious. There does seem to be a lot of work involved, but the actual math that you have to do is not hard as long as you are persistent. For the final example, we have x plus 3y equals 2 and 2x minus y equals negative 4. Now this one we could actually solve for x or for y in different equations, because both of them have a coefficient of 1. However, we are going to stick with the top equation because that one has a coefficient of positive 1, and that'll just make our lives easier. So rewriting it just so that I can use it easier or more easily, I solve for x, so I get x equals 2 minus 3y. And then I take that equation and plug that equation into my bottom equation, again replacing the x with the solution that I found in blue. After that, distribute the 2 into the parentheses and solve for y. Now that I have the answer for y, I need to turn around and substitute that answer back into the equation so that I can find the answer for x. And again, yes, I'm cheating and using a calculator, but that's okay. Now I have the answer for x and the answer for y, so I need to rewrite this as a coordinate point for my final answer. And that's it. So the steps that we've been following: step 1, solve for x or y, whichever one has a coefficient of 1. Step 2, substitute that solution into another equation. Step 3, distribute and solve for the only variable that's now in the equation. Step 4, use the answer from step 3 to solve for the final variable, and then you're done. That's it. Sorry it took so long. It's because I worked 3 different examples. Let me know if in the future you would prefer less examples so you have a shorter video. Go back, review the steps in order to solve a system of equations using substitution. If you didn't take notes on how to do it, go back and watch the video again, and that way you'll be ready for class tomorrow. See you later.